Sketch the locus of z if argz minus 1 take away argz plus 3 is equal to pi by 2. Now remember, this is the angle from the point 1, 0. This is the angle from the point -3, 0. So let's sketch and see if we can get an idea of what this is like. So I've got the imaginary axis here and the real axis out here. And if we put 1, 0 here, we can put -3, 0 out there. And just imagine some point that's somewhere in between them. So the angle from here I'm going to call alpha. And the angle from here I'm going to call beta. And so what we have up here is alpha minus beta being equal to pi by 2. Okay, so let's consider this angle up here in this triangle. This angle here would be pi minus alpha. The angle then at the top is going to be pi, take away the other two angles. So take away pi minus alpha, take away beta. And so that angle there has that size. And that's going to be pi minus pi plus alpha minus beta, which is alpha minus beta. So the angle at the top of the triangle here is alpha minus beta, but alpha minus beta is pi by 2. So this is a right angle. Now, if we know that that's a right angle, from what we know of circle geometry, that means that that point must lie on a semicircle with the endpoints at 1 and -3. And so the locus is actually going to be a semicircle going around between those 2 points. Now, would it also apply in the bottom half of the diagram? Well, the answer there actually is no. And let's just look at why. Let's imagine a point here. Then this would be our alpha, and alpha would be a negative angle. And this would be our beta, and that would also be negative. But alpha is more negative than beta. So alpha minus beta would definitely not be equal to pi by 2 in this situation. So it's just a semicircle in the top half, and of course the points actually on the axis are not included because you can't really talk about the angle of a point from itself. So we can't talk about the angle of the point 1, 0 from 1, 0.